All right, good afternoon or good evening once again. So today we are going to look at another topic under compute in the cloud. The first topic that we've covered under the compute in the cloud is AWS EC2 instance, which is AWS Elastic Compute instance. So the EC2 instance is a virtual machine on the internet or on AWS platform. Companies use more different kind of computes, and in the beginning of the class we started with the physical computer. There are challenges with physical computer, so companies tend to find ways that this challenge can be overcome. Especially one challenge that we have with physical computer, apart that it is not cost efficient to run one application on one computer. And if you are to run multiple application on one computer or on one server, it has its own challenges too. And one of the challenges is that when you run multiple applications on one single server, when you try to modify the server for one particular application, then you tend to disrupt the functionality of the other application. So that's why companies do not run multiple applications on one single server. They tend to have multiple servers and multiple applications run on different servers. One application on one server. So if you are to run one application on one server, then just imagine a company has 1,000 or thousands of applications. That means it's a lot of servers. And mind you, when we talk about scalability, then that means every one application will need multiple servers. So that is cost, that is ineffective way of spending or running our application, because you have to consider cost in everything. Cost and security are two of the most important things that you consider before you deploy any application. So with that being said, I will be introducing you to what is called container. And on the cloud, on AWS cloud, AWS call their container like AWS container services. There are multiple container services that AWS have. So we're going to be looking at them. For this particular course, we are not going to go deeply into any one of them, which we are going to be going deeply into them when we get to solution architect and security, AWS security. But this is just to introduce you to some of the compute AWS container services that we have. So let's go deep into, let's get in. So what is container? Before we go into AWS container services, let's understand what a container is itself. What is a container? Well, it's not like your regular container, just like when we say what is cloud, that a lot of people think that we are talking about the sky. No, when we talk about, or when we say container, it's not regular container that you use to package things that we're talking about. We're talking about compute container. So let me introduce you to, remember when we talk about the monolithic application, which is when you have your multiple components for applications running together. When you have multiple components of applications together in either a single code base or all of them in a single server. So we talk about the advantages of this monolithic computer, architecture, that all the components of the server, such as the user interface, the business logic, the data access code, and all of them into a single unified code base. And all of these are being run on a single server. And we talk about how this is not really the best practice because of single point of failure. And we introduce ourselves to microservices. We introduced ourselves, which was our last class. We talked about microservices. And microservices is whereby you separate these components into their own specific code base, and all of them can like interact together. And all this, the fact that we have all the components in their own separate code base, if we run these components, all of them, if we run them under a single server, there is going to be a challenge. Can you give me 1 second, please? So sorry about that. So if we run all of these components, we separate the components of the application into their own specific space. So if we still run all of them under a single server, we are still going to have the same challenge that we have with monolithic application, because there is going to be single points of failure. When one component is not working very fine, it might disrupt the operation of the entire system, and which might affect all other components. The applications or components won't be fault tolerant. They will not be able to withstand fault. If there is any issue with any of the application, it will technically affect every other one. So indirectly, we still face the issue that we face with monolithic application or architecture. And when you try to configure the server for one specific component, then that means you are disrupting the configuration of that same server for other components. It's just like two TV. If two TVs are using the same antenna, and you tend to turn the antenna in order to set the channel for one TV, then that means you are scattering the settings for the other TV. So that is the same way. If you are modifying the components of the server for a specific component, that means you are disrupting the configuration of that same server for the other components. So there are a lot of challenges with these components. There are a lot of challenges using one single server for multiple components. So, and the components cannot be isolated because they are inside a single server. And the major challenge of running multiple components under a single server is that those components cannot be isolated. So the second, or the main, or the first alternative or solution that might come to your mind for that challenge of running multiple components under a single server is that, okay, why not run each component on their own separate server? Well, if you run one component per their own server, that is a solution. But this has a multiple challenge, or it has multiple challenges, or they have their own challenges, because now when you run one single component per one physical server, then we are going to have, for these 4 components, we are going to have 4 servers, right? So the major challenge that might come to your mind for running our architecture or application this way is the cost implication. because now we are going to be buying 4 servers for this for application. Remember, all the applications do not require the same capacity. Some of them might just be, maybe they might run once in a month. Some might run once in 2 weeks, which means they don't really need a full server. And another component might need multiple servers because of scalability. So this kind of solution, or this type of solution, is not sustainable. So another challenge is that we have to manage multiple servers. So instead of managing one single server, you have multiple servers to manage. And when we talk about managing multiple servers, that means you are going to be configuring each server. So you are going to be ensuring there is no vulnerabilities on those servers. You are going to be patching the servers and all other administrative tasks. So this method is not sustainable and is not recommended because some of the server will be underutilized. Because if, let's say, for example, the business logic maybe it's only when somebody try to buy something on the website, that is when the business logic will go into action. But what if our website is not mainly it's not mainly for e-commerce? Maybe we just have a website and we just like maybe have a t-shirt that somebody can buy, and that is not our primary purpose of the business. Maybe we just put it there. Maybe some people admire our t-shirts and we just put it out there that, okay, anybody that needs it can buy it here. But for them to buy the t-shirt, they have to pay. So that might be the reason why we have the business logic, which might be for the processing of the debit card or credit card. And that might not run 24 hours. So that server that we are running, the third component, which is business logic, might be underutilized. So this method is not recommended, having one component per one server, one physical server. So another solution is using virtual machine. We've already talked about virtual machine when we are talking about EC2 instance. AWS EC2 instance is an example of a virtual machine. But every virtual machine, if you don't understand this before now listening, every virtual machine, they actually run on top of a physical machine. When you spin up an EC2 instance, which is a virtual machine, that EC2 instance is actually being run on a physical machine. Without a physical machine, you cannot run your VM. So when you go to AWS and spin up an EC2, that EC2 is being run on a physical server. So on that physical server that your machine, your VM, your EC2 instance is running on, that physical server has what is called the hypervisor. An hypervisor has already been installed on that physical server. And that is why you are able to run a virtual machine on a physical server. So the hypervisor is just a software that you can use to run multiple virtual machines on a single physical server. Because if you look at it, your VM, your EC2 instance, is just like a server. It's just like a physical server on its own, but it's virtualized. So the reason why, or the main reason why it was a physical server is able to be virtualized is because of the hypervisor. So on top of your physical server, hypervisor will be installed. Then it is on top of that hypervisor that you can now have your machine. So this is like the EC2 instance that you are running. On top of, underneath that EC2 instance, which is VM, is the hypervisor. So when you spin up an EC2 instance on AWS, you are spinning it on top of an hypervisor, but not necessarily that there are some VM that are not, you can install some VM directly on physical server without hypervisor. But majority of the time, you are installing it on top of an hypervisor. So the purpose of the hypervisor now is to make it possible for one single server to be used to run multiple virtual machines. So on top of this now, on top of this single machine, you can have multiple virtual machines. And then inside each of these virtual machines, you can then deploy each of those each of your application components. Like the components we are talking about, these 4 components, you can install it in each of these each of these virtual machine. So now the challenge of applications or the component cannot be isolated is not there again, because each one of them, they are running on their own specific virtual machine. So if you look at this virtual machine very well, we have a physical server. On top of the physical server, there is an hypervisor, and on top of the hypervisor, that is where we install our VM, or we created our VM. Then inside the VM, we deploy our application. So this is a more understanding of virtual machine, the full components of virtual machine. Remember, we have our physical server, which comprises the operating system, which is the processor, the storage, the networking, and other components. That's our physical server. And on top of that physical server, we have the operating system. Every physical server has their operating system. They can either be Windows operating system, Linux operating system, or Mac OS operating system. And this entire thing, the operating system and the hardware, form our physical server. And on top of the physical server, we have the hypervisor. So it is now the hypervisor that makes it possible for us to install or create multiple VM virtual machine on top of a physical server or physical single server. So now, inside each of these VM, that is where we deploy our application. Inside each of the VM, that is where we deploy our application. Now, you might be asking now, okay, we have VM and we deploy our application inside each of these VM. What are the components of this VM? So when we talk about virtual machine, VM comprises of the operating system. It has its own operating system. As the physical server has its own operating system, each of these VM, they have their own operating system too. So this is why it is possible for application to be isolated. When we have all the application under one single server, then it is very, very difficult for this application to be isolated, because this is our physical server, and when we deploy multiple application on the physical server, then it's going to be hard to share the hardware, because any changes that you made on the hardware for this particular one is going to disrupt the changes for this, disrupt the changes for this, disrupt the changes for this, or the hardware for that. So that is why the with the VM now, we can have specific settings or specific configuration for each of the application. So on top of the operating system for the VM, there is the binary and the libraries that the VM need or the application need to run. So for our virtual machine now, we have the operating system, we have the libraries, and on top of both the operating system and the libraries, that is where you now deploy the application. So now this is entirely our VM. All this is now our VM, virtual machine. So for VM, if somebody asks you, this has come out in an interview several times. So somebody asks you, a VM comprises of the operating system, the bin and the library, then you now deploy your application. So that solves our issue of application cannot be isolated. The issue of isolation can be solved with our operating system, with our VM. But okay, let's see. On the cloud, when we talk about cloud, especially those of you that are doing AWS, when we talk about EC2 instance, this is how your EC2 instance, so when you spin up an EC2 instance on AWS, this compute, this is what happened. This exactly what you are seeing here is what happened. We have a physical server in AWS data center. And on this physical server, AWS has installed a hypervisor. They have installed hypervisor. And on top of the hypervisor, that is where you are going to be spinning up your EC2 instance. So this is your EC2 instance. So if you spin up an EC2 instance in AWS, this is what happens. That is why when you are configuring your EC2 instance, or when you are filling the form to create an instance on the console, you have to select an operating system. And whichever operating system that you selected comes with the binaries and the libraries. So and then you can also install some of the libraries that you have or dependencies that your application need. So this is it here. You have the hardware, which is managed by AWS. You have the hypervisor. AWS also installed the hypervisor. Then you, the customer, will now be the one to select which operating system do you want for your VM. Then the library comes with it, and you deploy your application on the VM. So this is your AWS. So if you don't know that when you spin up an EC2 instance, it's actually being run on a single server in AWS data center. So that is why, remember, when you spin up an EC2 instance, it's going to tell you initialize. And during that period, you have to wait for it to fully initialize. And at the end of the day, when it finished initializing, it will tell you 2/2 checked. I don't know whether it's check or check status. And the reason for this 2/2 is telling you that the first one is checking the physical server, whether it is fully running. And once the physical server is successfully run and is in a good shape, then it's going to check your instance. This is why you see this one as 1 and this one as 2. That's why I tell you 2/2 check. So that 2/2 check that you always see when you spin up a server, this is what is happening behind the scene. It's making sure that, okay, this is running. When you see it is running, you say 1. Then this go next, the hypervisor. That is why in most cases, when there is an issue with this underlying physical server, there is an issue with this. So at times you might just say that your server just stopped, or maybe you go home and you come back the next day and you discover your server has stopped. It might be something wrong with this one. Then once something wrong with this, is going to affect your system. So in most cases, AWS, they must have tell you or send you a message like, okay, on so date, we are going to change this server. They always, that's why they have an help check. They will tell you, if you go to your AWS account, they will tell you maybe on a particular date, they will conduct an F check for this instance. So they tell you in advance whether to stop this, or maybe just to let you know that, okay, when you come back the next day, this server or this your EC2 instance that is running on this server will not be on this physical server again. They might have transferred your EC2 instance to another server, and that might disrupt your EC2 instance. So this is how a EC2 instance runs behind the scene. So it's actually a virtual machine. That's why they call it virtual machine in the cloud. When the operating system that runs on the physical server, the operating system that runs on the physical server is referred to as the host operating system. Why the operating system that is run or that runs on the VM is called the guest operating system. So when somebody asks you what is the difference between the host operating system and the guest operating system, I believe you know it now. The host is the operating system that is running on the physical server, while the guest is the operating system that is running on the VM. So I said earlier that virtual machine, VM, actually solved one of the challenges that we face if we want to run multiple applications on one single server. If you just join in, one of the challenges that we say you have when you remember, we have 4 components when we convert a monolithic application. When you convert a monolithic application to microservices, the challenge that we have now is that this microservices is not running. So monolithic application is like one giant application that have different components under the same code base. But when we have monolithics, that is when we now divide that giant component into small components. So the challenge we have now is that these components, all of them cannot be run under one single server, because it's going to disrupt the components. At the end of the day, what we are trying to achieve, we won't be able to achieve it, because we want each of these components to be independent, to be fault tolerant. But if you run all of them in one single server, then it's still going to they are still not going to be independent, because if we make changes to the server for these components, that changes that we make for this component will affect the settings for this. We affect the settings for this. We have set the settings for this. So the best option is not to run all of these components in a single server. Then the alternative option that we discuss is that you can have one server for one component. So this component use this server, this component use this server, this one use this, and this component use this 1 second. This one use this server, and this component use this. But the challenge that we have in this kind of architecture is that we are going to be dealing with multiple servers, and the first challenge is cost implication. The second challenge is management. You have to manage multiple servers. So we don't want to manage multiple servers. So then we discuss the other other solution is to have a virtual machine. With virtual machine now, we're going to use single server. But on top of this single server, we are going to have different virtual machine, multiple virtual machine. So now you can see that, okay, we are using single server, but on top of them, we are using single machine. So this application now, we can deploy this on this, this on this, this on this, and this on this. So you can now see, but guess what? We now have only one server to manage instead of multiple server. So that is one solution. And I mean, that's another solution to our challenges. But all of this VM solution, it also comes with its own challenges. And the challenge with this VM, the challenge that we have with the VM virtual machine solution is that every virtual machine comes with their own operating systems. They come with their own operating system. So that makes it highly resource consuming. It consumes a lot of resources because look at it. Everyone has his own operating system. Operating system can be huge, can be 4 gig, can be 3 gig, can be 2 gig. So if just look at it, let's say, remember when on this operating system, when you install operating system on the VM, it's actually being installed on the underlying hardware, which is the storage. So there is limits to what you can install here. So that means it's also not really scalable, because by the time we start installing multiple virtual machines on one single server, then it's going to come to a time that we cannot install anymore because the operating system is fully utilized, the processor is fully utilized, the networking is utilized, and other components are fully utilized. So those are another challenge with VM. And the main challenge of using VM is this here. Everyone comes with their own operating system. So VM requires separate operating system for each virtual machine, which makes it hard to scale. Managing multiple VMs such as patching, security configuration for each of the VM can be complex and time-consuming, because if you have multiple VM, that means you have to deal with each of these VM. You have to configure them, you have to patch them. And another challenge is that if there is a security vulnerability with this hypervisor, because the hypervisor is between the hardware, which is the physical server, and the VM, the vulnerability with this hypervisor can affect your physical server, which can also affect the VMs. Though each of these VMs are isolated, so you can say if there is a misconfiguration here, then the misconfiguration will not transfer to this, will not affect this, and will not affect this. Yeah, that can be true to some extent, but if there is a misconfiguration here or security vulnerability here, it can affect your hardware, your physical server, and it can affect each one of these VM. So that's why we are looking for, I believe there is no solution that is 100%, but managing multiple applications with VM is not always the best. So what do we have? Then let me introduce you to container. Container is more like VM. Container is more like VM, except there are some little changes. And one of the main changes that differentiates container from virtual machine is with virtual machine, we need an hypervisor to be able to run multiple virtual machine on a single server, because this hypervisor now makes or expose this hardware to the VM. It's like the one helping the VM to manage this hardware so that they are not affecting or they are not fighting each other for the hardware. So the VM is just like a middleman that help them, hey, you hypervisor 1, hypervisor 2, hypervisor 3, hypervisor 1, I mean VM1, VM2, VM3, VM4. You might like, oh, VM1, you need 20 gigabytes of memory. Okay, there is memory here, take 20 gigabytes. Oh, hypervisor 2, you need 10 gigabytes of memory. Okay, there is 10 memory, take. So we had them to like distribute the underlying hardware without any one of them having issue. That is the purpose of the hypervisor. But now with container, we don't need hypervisor. Instead of hypervisor, what container use is the container engine. Container use container engine. So instead of hypervisor now, what we are going to install on the operating system is the container engine. And there are multiple container engine out there, but the common one is the most common is the Docker container engine. Then we have the containerd and CRY-O too. But there are other container engine out there. So with the help of container now, every virtual machine do not need guest operating system. So now, instead of calling it virtual machine now, we now refer to this one as package. Or we call it image. So now, instead of having a virtual machine that comes with operating system, the libraries, then the application, with the help of container, we only need the application and every dependency that the application needs to run. So now we don't need operating system, guest operating system again. So now this is it in a more clearer way. We have the physical hardware. The physical hardware is still there, but instead of installing the hypervisor now, what we are going to be installing is the container engine, which Docker is the most common one. And on top of the container engine, then you can now run your package, which is your which is your image, or which can be referred to as your image. And each image comes with your application and the binary or the libraries or the dependency. So for a developer now, if they develop an application, all they just need to do is to put the application in a container and the dependency that the application needs. And all of this they bind it together or they build it together and they call it image. And so this image, anytime it wants to run the application, it is you just make a copy of this image and you put it on top of your Docker engine. And that is all. Your application will start running. So you can see now that with this, it is now easy to ship an application or to send an application, because guess what? The hardware, I mean, the operating system can be like 2 gig, while the application can just be like maybe 200 megabytes plus the dependency. So now we don't need this hardware again, this operating system. So it is now easy to send this to anybody. So now it reduced a lot of costs. Just imagine if you, let's say our hardware, or at least our physical server has like 200 gigabytes of storage. If we are to install virtual machine, and each virtual machine comes with like 2 gig, so that means we can't install more than 100 VM on one single server. But with when now that we don't need the physical system, I mean the guest operating system again, just imagine how many 200 megabytes that you can run on 200 gig. Remember, 200 gig to megabyte is like 200,000. So now if you divide this equation, that means you are running almost 1,000 image if you are running container, compared to you are running compared to you are running 100 if you are running VM. See the difference. 100 VM to 1,000 container. So when you are running container, there are 3 main things that you need to be worried about, or you need to be concerned about. One is where your container will be run. Because remember, container is just like a package, just like a box that is contain your application and the dependency. So this application plus dependency, we need a place for it to run. So it can either be run on a physical server, just like what we have here, physical server, or it can be run on a virtual machine. Yes. It can be run on a virtual machine, just like we have this. Let's say this is our physical server. On top of this physical server, we have our virtual machine, VM. So inside this VM, we can have our container running inside this VM. Or you can run the container directly here. And you can also run it on serverless. We have not talked about serverless now, but serverless is just like, instead of having your EC2 instance, when you create an EC2 instance and it starts running, then you can now decide to deploy your application later in it. But with serverless, you don't need to deploy an EC2 instance. Anytime your customer wants to run your application or want to interact with your application, a server will be created on the go automatically for you by AWS, and they will deploy your application. The user will use your application, and when they are not using it again, system terminates. So you are not incurring costs of leaving your server running 24 hours. So if there is a serverless that you can use to run your container, and that is on AWS, that is Fargate. So on AWS, there is still more here. So we have the compute, that is where you run the container. Then the second one is where you are to keep the image of the package. Remember we said container is just like a package that contains your app and dependency. So the app and dependency, once the developer creates this package and the dependency, they needed to keep it somewhere. Where they keep it is what is called registry. And there are multiple registries out there. The most common one is Docker Hub. Then AWS also have is Elastic Registry Service, ERS. Elastic Container Registry. Sorry. Elastic Container Registry. But the most common one is Docker Hub, which is owned by Docker. Then once you see the container, the compute is where the Docker is being run, while registry is where you keep the package before it will be run. If it is not being run, you can keep the package here. Anytime you need to run your application, you can copy your application and you can start running it inside compute. And the next one is the orchestration. Orchestration is when you want to manage multiple containers. If you are to manage one container individually, it's going to be complex. So you need a system or a service that can help you to manage multiple containers. Just remember when we talk about auto-scaling under AWS, that when you are not there, AWS auto-scaling system can create a server for you, deploy your application on the server, and terminate a server if the server is not being used. With container, we can still do the same thing with the help of orchestration services. So when you are using Docker, native Docker, you can use Docker Swarm to manage multiple containers. But if you are running, there is another alternative which is more better, and that is Kubernetes. So AWS have its own managed container registry. They have their own managed container Kubernetes service called EKS. Kubernetes is one of the complex tools to configure, especially the installation, because it comes with a lot of different components. When you are installing container, there are some container that you use for POC, proof of concepts, or when you are doing developmental job, maybe you are learning, then it can be easy to configure. But if you are deploying container for enterprise, Kubernetes for enterprise, you're going to deploy a master container, master node, which is commonly referred to as control pane, sorry. Then you're going to have the node server. That is the node, the master node and the node. So to control this, to install this, it can be complex, but it's not that it's not doable, but it has a lot of components. So instead of you go through the stress of deploying your master node, AWS have a service called Kubernetes service or Amazon Elastic Container that can help you with the process of this. They just give you a pre-configured master node. Then you can now be creating your worker node. You can be creating your worker node for your deployment. For your deployment. So those are the three major components that you really need to focus on if you are dealing with container. I will repeat them. The first one is where your container will be run, which is the compute. And you can either you can run it on a physical server, or you run it on an EC2 instance, which is a VM, or you run it on a serverless, which is on AWS is called the AWS Fargate. Then where the image can be stored, if you are not running them, when you create an image, then the image need to be stored somewhere. And the most common place is Docker Hub, or if you are on AWS Cloud, you can use AWS Elastic Container Registry. For the orchestration, that's when you're to manage multiple containers. Then you need an orchestration service. And the most common orchestration service out there is Kubernetes. And Docker also have its own called Docker Swarm. Or you can use AWS Elastic Kubernetes Service. So the AWS Container Service is a fully managed container orchestration service that helps you to easily deploy, manage, and scale container application on AWS. And it is pre-configured by AWS with operational best practice. So remember when I talk about the like example under the Kubernetes that you have to create the master node and the worker node. Master node is always the most difficult to create. Not that it's actually difficult, because whatever you install on master node, you also install on worker node, except some few different things. But the process is always complex. So that's why AWS, they have managed services that they have already configured for you to use. First of them is the Elastic Container Services. And then we have the Elastic Kubernetes Service, which is also an orchestration service, but a managed service. A managed service, but you can also use it. If it goes to the cloud, let me see. So for the, I'm not deploying this, so because it's not part of the curriculum. I just want to show you ECS. This is the AWS Container Service. And under the AWS Container Service, you can see, if you know Kubernetes or Docker, you can see that it's exactly the same thing. Under your Kubernetes, you're going to have a namespace, you're going to have a cluster, that then you define your tags. This is the Elastic Container Service. So if you create a cluster, when you talk about cluster is just like if you are deploying an application. If you are deploying an application, you can have multiple servers running the same application. Remember how we used load balancer the other day, that the load balancer is switching between two servers. The same thing, those two servers can be referred to as a cluster server. When you talk about cluster, it's just like you have multiple servers, all of them running as a giant as a member of each of the node is working as a member of the cluster. So most of the time, all of them are running the same application. The same thing is going to be run on all of them most of the time. At times, something can be different. So under this cluster, you have multiple servers. So managing these multiple servers can be complex. But the first thing you need to do is to give name to your cluster. I can call this a web server. And once you create your web server, you're going to give it a namespace. When we talk about namespace, so let's look at this server now. You can see that this is multiple servers. Under these servers, you can put them in a separate namespace. You can say from here to here, it's going to be managed by, it's a server for security team. These two, the server for networking team. And the remaining is for developers. So this is like you, inside the same cluster, you are dividing the cluster into separate units called their namespace. So when you want to add node inside your cluster, you have to specify inside which namespace do you want to add a new node. If you do not specify, it's going to add the node in the default. There's always a default. It's going to add the node in the default namespace. So here you can specify what is your default namespace. And if you open, you see this is one I've worked with in the past. So you can create your namespace. I can call this one web server cluster. Oh, remember we have coffee cluster, coffee server cluster. Then we can use that as our default namespace. Then remember when I was talking about where to deploy the server, you have to pick. Do you want to deploy it? Remember when we're talking about this, that the three main things that you need to focus on are compute, registry, and orchestration. Compute is where do you want to deploy the container? And when we go back here, this is what this is asking here. This is what this is asking here, that the infrastructure, do you want to deploy it inside an EC2 instance, or do you want to deploy it inside a Fargate? If you are deploying it inside a Fargate, you don't need to do any configuration. But if you want to deploy it inside a EC2 instance, then you have to set the auto-scaling group, the pricing. This is, if you look at this very well, you will remember that these are more like what we configure when we are creating our EC2 instance. You pick your AMI, you pick your instance type, your roles, though we have not talked about role, pick your key pair and your root device size. Then this networking, you also specify your networking, and the remaining are not really necessary. So let me just put some things there just to create this. So I'm just going to go with what we have currently. I'll say create a new security group, auto-scaling group, and I'll just leave everything the way it is. So I'll just say create. So what he has done now is that he has creating a cluster. A cluster is, so this is what he's doing. He's going to register a cluster. And inside this cluster, we have picked that we want to deploy our application. And the compute that we pick, where the package will be deployed, is EC2. So it's going to be creating multiple EC2 for us as we deploy our application. So remember, we also select auto scaling. So the auto scaling will go into action and be creating the servers for us. So if we need more, the auto scaling is going to be creating more. But I'll leave this here. So for the Elastic Container Service, EKS, so this is just, you can see the same thing, add your cluster, and once you add your cluster, you select a row, then you do your settings. This is not really much to do here, but this is for, I'm just showing you the service, not really going deeply into it. If you, for the registry, Elastic Container Registry, ECR, there is the registry. And this is just where to, when you create the artifact, your container registry, your container image or your image, you will go to store it somewhere. And this is for the AWS. If you want to use the Docker Hub, just do Docker Hub. This is it for Docker Hub. Just go to this website and you can create an account there. And yeah, you can see if I search for an application or an image, let's say, let's do for Python. So if you look at this is just like a machine, an image that has already been configured. But inside that container, there is Docker, there is Python installed. So it comes with Python application. And you can see that almost 1 billion people has downloaded. Almost 1 billion people has downloaded this. So if I also want to download this, I just need to click on it to open and go to copy this Docker pull Python. So if I go to my, let me open a VM, folder. So if I go to my terminal and I say, if I paste this here, Docker pull Python, it's going to pull this Docker container. It's going to pull this on my system. And once it pull this on my system, say the system cannot specify open. Okay, I can, let me see, do I have any EC2 running? Let me see. Okay, I don't have anyone, but let me see, do I have any EC2 configured? Okay, let me just start this. Oh, time has even gone. So if I start this now, I can pull that container on this server. And when I open it, it will just run like the normal server. Because somebody has created a Python, which is a software, and has put everything that the Python needs to run. And when I take this container image, I just need to have a place to run it. And that is where I'm creating this EC2 instance so that I can run that container image on this EC2 instance. When I run it, then when I'm done with it, maybe I downloaded another application on it, I need to keep it somewhere so that other people too can go there and pull it. And you can see when I go to Docker Hub, I was able to pull this. So this is where it is being stored. So if I paste that same code here, container pull, let me see, say sudo install. Okay, I have to install Docker first. Let me just use now sudo Docker install. I mean sudo yum install. It is Ubuntu. Ubuntu is apt. Sudo apt install Docker. Yes. So remember, this is just what we discussed. Like your physical machine, you're going to install Docker on it. Then that is when you can run your container. So you can either run your container on physical machine or you run it on VM. But whichever way you are running it, you have to install the Docker engine, the container engine, which is Docker. And that is why this is asking me here to install Docker. Now that I've installed Docker, I can now go and install my image, which is Docker pull Python. Still want me to... So I understand why this is not running. Docker not found but can be installed, snapshot Docker. Because I'm using this one for my Kubernetes. You will see, I think that's meanwhile it's not running, because this is just, I'm running Kubernetes on this system. This is my Kubernetes manager, my Kubernetes master node, and these are the worker node. So let me see if I can run it on this second machine. This is the machine that we created for our coffee. So hopefully that will work. Let me try on that. Let me see if I can quickly go up. Remember this check that I was telling you that I always ask for check of 1 of 2. This is the status check, 2 of 2. It's checking for the physical server, and it's checking for the instance, and say both of them are passed. That's this. We discussed that earlier in the class. Okay, so let me see if I can install Docker. Sudo install sudo install. This is now sudo install Docker. So Docker is going to be installed, and once Docker is installed, then I can start using it for my package, for my VM. I mean for my container. So now I can now download my container, Docker pull Python. Say cannot connect to the server. Is Docker daemon running? Let me see. Okay. Let's see. If I do not specify anything, it's supposed to run the cannot connect to the Docker daemon at units. Docker daemon running. Let me see. Let me try to pull another thing. Ubuntu. They cannot connect to Docker daemon. Let me see. Okay. Sudo su dash. Yeah, I have to run this on root. Let me see. Using default calculators, come on. Okay, let me see. Is there any version that need me to install? Let's see, tags. then the specific tab. Paste Docker pull. I don't remember my password again. Let me just say, okay, that works. So let me try it again. It's gonna work. No, okay, I know what to do. Let me just log in. I want to pull my own. I actually have a account. Local pull. I'm not connected to Docker daemon. I don't know why it's giving me this error. Let me see. It's okay. Docker. Okay. So when I install it, I'm supposed to start it. Let me check. Remember the other day when you install package, you need to see if it's running. So the system ctl status Docker. Yeah, I say Docker is not running, it's dead. So I need to start Docker. Docker system ctl start Docker. So Docker is started, then let's install. Okay, it's working now. Yeah, that's my mistake. I'm supposed to start it when you install a package, you need to start it, otherwise it will not start. So now you can see it as if I do Docker image. So it tells me that I have one image. So this image is a container, is a website that is actually I have all the dependency of that website inside this container. So it's just a website with its dependency. So I can run this website now. And when I run it, it's going to, when I run this container, it's actually going to, you're actually going to see the website. You're actually going to see a website running on it. So it's a full website, but we are not going to go deeply into that tonight. But just to show you. So the three things that I've said, we've discussed it. You need a compute where your container will be run. So we pick an EC2 instance. Then you need a Docker registry or a registry where the container or the image will be stored. And you can see there are a lot of images that are stored here. So if you just check, like, let me see, or you will see different lot of image container that people have created. And each of these is just an application with their dependency. So it's easy to save because, and you can easily send this to somebody. So because now you don't need an operating system, you just need where to run it and where to store it. And if you are running multiple, then you need a way to orchestrate it or manage it. So that is container for you. This is not a topic to actually teach you about container. Container is a big topic on this one. This is just an introduction into container. So the image that I spin up here, if you, maybe in the next class, I might show you, that's the only way if we have time, I can actually run this image. I just say docker run -it dash name. I'm going to give it web server name coffee dash p is 80. Then the name, I can give it it's called AAY docker run it dash name is coffee dash pit port is this. Then the image name is no, something is wrong there. Docker run dash help. Okay, let's see. Image. I want to see how you specify image. Image is host is this, IP is -p, publish expose port -p, I-t, -v-2, interactive. Yeah, that's correct now. Yeah, so if you don't understand what I'm doing, that is actually not a problem. What I'm just doing is on Docker, there's a command called docker run. And this command, if you want to actually know the command or the flag that you can run with it, or what the command is doing, you can do docker run dash help. Then it's going to give you all what you can run with command. And same thing with any CLI or any command. If you type the name like AWS, now say AWS dash help, AWS dash help, it's going to give you all what you can run with AWS, like AWS EC2 like dash help. It's going to give you all the command that you can run with EC2. So it's not stable. AWS yeah, it won't say AWS because I don't have AWS on this system, so it won't say the Docker dash help. So see, these are all what you can run with Docker. You can see you can run except PS, bridge, pull, push, image, login, all those commands you can run with Docker PS. But if you don't have an application installed on the system, you can't do Docker. For example, if you have Git, you can do git dash help. And it's going to give you, so I don't have Git here, so that's why it's not saying it. All right. But possibly in the solution architect, we will go deeply into this and we actually create our container and run container image and deploy an application in the container. But this is just an introduction into container. All right, I'm going to stop here. So just to recap what we've learned today, we started with container. The major issue we have is, let me go back here. The major issue, we have our physical server. We have our physical server, or let me say we have a monolithic application that they are tightly coupled. And for this, because of being tightly coupled, they have fault tolerance. The fault to one of the components will affect every other component. So in order for this, in order to solve the issue of tightly coupled, we convert our application to microservices, which has different components separated or has all the components separated from each other. But having multiple components now, if we deploy all of these components on one single server, then we still have the issue of not being fault tolerant. We have the issue of they cannot be isolated. Each component cannot be isolated. So those are the challenges that we have if we deploy all these different components on one single server. And to solve this issue, we talk about deploying each of the components in their own specific operating system, physical server. So each component will be deployed in a separate server. But this is not sustainable because you're going to be managing multiple servers, and that will incur a lot of cost. So the alternative to this, if you don't want to use multiple servers, is to use one single server. But on top of that single server, we are going to deploy what is called an hypervisor. And once we deploy that hypervisor, it will make possible for us to deploy multiple instance or server instance on that one single server. So that is the alternative where we can, if you don't want to have multiple physical server, you can have only one single server and deploy each of the components in a separate VM. So we use VM2. Then the problem with VM is that it comes with its own operating system. It comes with its own operating system, which can be resources consuming. So we need a situation, or we need to solve this challenge, because just imagine if you have 1,000 applications and each one of them have to have their own operating system. So that means you're still going to be incurring a lot of cost. So we need, in a way, to do away with this operating system, which is called the guest operating system. Then we're introduced to container. Container does not have its own operating system because it utilizes the container engine. So with the help of the container engine, which the most popular one is Docker, we don't have to install a physical or a guest operating system on our VM. In fact, we don't need VM. All we need is our application and the dependency that our application needs in order for it to be able to run. So together, the application and its dependency is what we refer to as image. And when you create an application and you package it together with its dependency, which is called an image, this image needs to be stored. And where you store the image is called registry. It's called registry. And this registry, there are multiple registries out there. The most popular one is called the Docker Hub. But if you are working with AWS, AWS have its own cloud registry, which is called AWS Container Registry. EC, AWS Elastic Container Registry, not AWS. It's called Elastic Container Registry. So this is where the image will be stored. And whenever you need the image, you just need to pull the image from the registry into wherever you need it. So wherever you put it, that is where you are going to be running the image. So you can run the image on a physical server or on a VM, like EC2 instance, inside a VM on the on-prem or on EC2 instance. Or you can also use what is called a serverless. And on AWS, we have a serverless called Fargate. So when you have multiple images that you need to manage, then you need a way to orchestrate them, to manage them effectively. And that is why we need what is called an orchestration services. And the most popular orchestration service out there is Kubernetes. Or we have Docker Swarm, and AWS have its own called AWS. AWS have a managed version of Kubernetes called EKS, and they have another one which is just a managed service too called Elastic Container Services, ECS. So these are what we discussed today, and this is where we are going to stop. Any question? All right, if there is no question, remember when you are rewatching the video, you will surely have a question. You can post the question on our Telegram. And for those of you that are watching this on YouTube that might have any answer, you can post your answer in the comment section, or you can also join our Telegram. With the link will be in the profile, I mean, in the description box or the under the comment section. So you can also join the Telegram. And if you want to join the class, you are also free. You also see the link to join the class there. All right. Yeah, go ahead.
I heard somebody say something like bare metal, have a bare metal without operating system. I don't know how that works, or is it necessary for this class?
I don't understand. I didn't hear you clearly.
What is bare metal when we say bare metal?
Bare metal, okay. So
I don't know if
yeah, I understand you. I understand you. So when we talk about, let me see if I can. I actually need a. Let me see. Okay, let me use this one. So when we talk about container, I mean, when we talk about hypervisor, you have a physical machine. This is your physical machine. Like from here, okay, let me from here to here is your physical machine. Okay, let me go back. There is a better one that I can use. Let me go back. Okay, so if you look at this, let me see if I can go back one more step. Okay, this is better. So if you look at this very well, from here to here is our physical machine. So on top of the physical machine, there is a hypervisor, which makes it possible for us to be able to install our VM. For us to be able to install our VM. But there are some time or cases, it depends on what you're talking about, that you might not need this. That you can install the VM, or you install an application directly on the hardware. That you install an application directly on the hardware. So in this case, we don't need this. So you can install an application directly on this place. So there is no need of the the hypervisor. And in some cases, what they might refer to as bare metal is that if you are talking about OS and hardware, you can install then your application here. You can install your application on the hardware directly without this. And that is what they refer to as bare metal, that you are installing directly on the physical server or on the physical hardware instead of the middleman that you have here. All right, any question? Any
Okay,
other question?
but if we install it, if the operating system and the hypervisor go together, what operating system will the system now use?
So
I don't know if that.
it actually depends on the application, because there are some applications now that you don't need to install them in the operating system. They work directly on the, I mean, they don't need they don't need an hypervisor. They work directly on the operating system directly. They don't need an hypervisor. Yeah. So that kind of application must have been configured or created to use or to bypass hypervisor, or must have been configured for not needing the help of hypervisor to be able to talk to the underlying hardware.
Okay.
Yeah, but majority of the compute or you see VM that you see out there, like 80 to 90% of them, they actually use hypervisor. So if you go to AWS now and we've seen some instance, if you go to instance type, you will see some that are called meta, bare metal. Bare metal like this. So they are kind of the instance that they don't have like hypervisor, they're just like direct. All right, any other question? Okay, if you don't have question, please let's meet on Saturday. If you remember, if you're watching the video and you have question, you can drop it in the comment section. Or if you are a member of our Telegram, maybe if you join our Telegram, you can put your question on our Telegram. And if you also want to join the Telegram, the link will be in the section. I mean, under the video, in the comment section. All right, thank you guys.
Thank you very much.
Thank you.